are using two type of method. First one, that weighted residual method. Weighted residual method. Then second one, variational method. Variational method. Then after solving this, we will go to some problem, because we already covered half of the. Okay, like we will solve one problem, then we will solve it too. So let's we are going to take one example to understand the method. So let's assume that we are having one differential equation. Example, we are having one differential equation minus du by dx2 equal to sine pi x in the range of 0 to x to 1. This one we can solve easily by using our that normal technique, whatever we study in the till now. And we are having boundary condition at x equal to 0, e will be 0, and at x equal to 1, again e will be 0. So these two are okay. So just we have to find here one thing, like we are having order of differential equation 2. We are having order of differential equation is 2. So now we have to find how many we are having that essential boundary condition and how many we are having natural boundary condition. So like 2p equal to 2 equal 2p equal to 2, which means p equal to 1, then zeroth order will be our essential boundary condition, and first order will be our natural boundary condition. So here we are having two boundary condition, these two boundary condition, and these both are zeroth order differential boundary condition. So these will be our two essential boundary condition. Okay. So from here, what we can say that this is not compulsory that every time we will get like natural and essential. Sometimes we will get essential, but we will not get any natural boundary condition. That one just I want to tell you from this example, this whatever I wrote here. So now we are going to solve this differential equation by using exact solution. So solution by, or I will write exact solution. Exact solution we can do easily, like minus du by dx2 equal to sine pi x dx. Then we are going to integrate once, then that it will become minus du by dx equal to minus 1 by pi. Sorry, it will be cos, not sine. Minus pi cos pi x plus c1. One constant will come. Again, I'm okay. So that will be, it will be du by dx only. Then again, I'm going to integrate with respect to x. Then again, it will become minus u equal to minus 1 by pi square sine pi x plus c1x plus c2. So this will be our that solution of u. And we have the two boundary conditions. So these boundary conditions, what boundary condition we are having? Boundary condition at 0 equal to 0 and at 1 again equal to 0. We are going to use, so if I use this one, then what we will get? 0 equal to 0 plus C2. It's mean that C2 equal to 0. Then from this boundary condition, we will get 0 equal to, this will be 0 plus C1 plus already 0, then C1 will be 0. So finally we got U equal to, we will send minus this side. So 1 by p square, 1 by pi square sine pi x. So this is our exact solution for this differential equation. So this is our exact solution. But this is not true for every time, because sometimes we are not able to solve by using our technique. So for that, we need to use some approximate method. Then what is the meaning of exact solution? Exact solution means, okay, I just want to tell you one thing here. What is the meaning of exact solution? Exact solution means, if I will say this is our LHS. Oh, okay, I will write here then. Oh, then I will write minus sine phi x. So I will say this is our LHS left hand side. This is our RHS side, right hand side. So what the meaning of exact solution? Exact solution means if 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 I will keep this u, like if I will replace this u, like I will put u here, and left, if I will put u in left hand side, should get RHS side. In other word, like both sides should be same if it is having exact solution. So just try, if you will keep, if you put here this this one, you will get same. Like, okay, let's try. So we are having u, then we will find first time differential equation du by dx equal to 1 by pi square, then d by dx sine phi x, it will become 1 by square into pi cos pi x. Okay, then again d2 by dx2 equal to, it will become pi, then cos will become sinus minus sine pi x, and when 1 pi, it will become again minus sine pi x. So we are getting same. So if I will replace u in this differential equation, it should be same as the right hand side. It is this is the meaning of exact solution. So this is our exact solution. But as I told you, this is not like 100% true that we are getting exact solution for all the problem. Sometimes like problem is very complex, and we cannot solve by using that by our handwritten technique. So we have to use some modi, like we have to use some approximate method. Then as I told you that we are having something like this two method, or we are having more, but this is the like, just for example, we are having two method. First one that weighted residual method, then second one variational method. Okay, so this is our exact solution. This is our exact solution. So in approximate method, what we are saying, we are having equation we have equation minus dt by dx2 equal to sine phi x. This is our second order differential equation, and we are having boundary condition at 0 equal to 0, at 1 equal to 0. So now I will say that this u, if I will assume ux equal to a naught plus u1x plus a1x plus u2x square plus u3x cube plus dot 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 dot. So this is the assumption that I am saying this function u will follow this the polynomial. Okay, this is assumption, so we will get some error. So I will say that, but like I will say this is our, if we are assuming something, then we are going to get some error. So I will say this one error ex equal to minus du by dx minus k sine pi x. Now this is error we are getting. Okay. So if we are assuming something that as I told you, this difference this equation I want to solve. This is simple equation that we can solve by our handwritten solution. But sometimes it is not possible to solve by that whatever we study in that school or that college, that first year, second year. So in FEM, what we are doing, we are assuming some function that I will say this u will follow this polynomial. But when we are assuming something we will get some error e. I will say we are getting some like 10%, 20%, whatever percent we are getting some error. So I define one function e is the error function. So this is the error function. Okay, that's fine. Then what is the weighted residual r equal to integration wx ex into dx. So what is this? What is this one? Is the some weight function, and this is the error function. Okay, now are you getting something? Okay, that's fine. So this is our that weighted residual function. Okay. So now this function we have to decide. This weighted function we have to decide. So we are having different technique. For example, to decide that weighted function wx. To decide weighted function, we are having different technique. First one, least square. Okay. Second one, collocation method. Collocation least square method. Third one, collocation method. Or third one, Galerkin method. Did you heard these name like before? like coming to this class?
Sir, I had only heard about Galerkin method.
Okay, so now you got now like what is the what is Galerkin method? So to decide this weighted function, we are having different method like least square method, collocation method, and Galerkin method. So this one normally we are using FEM. Normally we are using normally in FEM. Normally we use in FEM. This one. Using using FEM. So okay, so I will summarize once again. Like we are having one differential equation, and I want to solve that differential equation. So this is like whatever we took this if equation. This is simple, so we can solve by using our that technique. So what we got? We got this is the exact solution. Okay, but now I'm saying I don't want to solve by this. Sometimes we are not able to solve by using that exact solution. So I'm saying I'm assuming one function. That function following one polynomial. It can be like sine, like it can be other trigonometric function as well. Just for simplification, I am saying this is following one polynomial function, and if I'm assuming something, it will have some error. So I am saying this is error that I am getting while assuming this ux. Okay, so what is the weighted residual? It is saying like this error we have to make it minimize. So ws into ex into dx. What is wx? Ws is the weighted function and ex is the error function. Now to find this weighted function, we are having different method. First one least square method. Second one collocation method. Third one Galerkin method. And okay, so now one more thing I want to add here. So in least square method, whatever weighted function we are having, it will become error function itself. So like we are here we are having two w and ex. So in least square, it will become both will become same. In collocation function, there will be one direct delta function, direct delta function, and in Galerkin, our wx in wx we are going to use some function. Wx will be some function. Okay. I think it's taking long time, but okay, I just want to finish it fast. So you are not getting bored, right?
No,
You,
sir. No, sir.
okay, that's fine. So now, as I told, like first, I believe I will go through that least square method. So least square method, least square method. So in least square method, whatever error function we assume, that will be weight function. That we have to remember. Whatever error function we assume. So whatever we did, this is our assume function. So ux equal to ux a naught plus a1x plus e2x square. Then we are having two boundary condition. First one u0 equal to 0, then u1 equal to 0. So now I will put here. So we will get take 0 equal to 0. So 0 means a naught 0. Then again 0 equal to 0 plus a1 plus a2. It means that a2 equal to minus a1. A2 equal to minus a1. Okay. So then find what we are going to do. Now we are going to replace. So our ux will become ux equal to minus a2 x plus a2 x square. Then I will take a2 as a constant out. It will become x square minus x. That's fine. So okay, so this is called our trial function. Like for why I call this one trial function, because like assume function, this is called like trial function. Trial. Like I'm doing some trial and error to get the exact solution. So I assume this is our trial function. Okay. So so this is our trial function of ux will be q2 a2 x square minus x. Okay, fine. So but what is our error function? Error function we are having error function ux equal to dt by dx2 minus sin pi x. Okay, so now I'm going to push this u in this equation. So what we will get ex equal to, this is our error function. Error function. So what will we get? That we have to differentiate 2 times. It will become this 2 a2 2. It will become 0. It will be 2 2 minus a2 minus sin pi x minus sinus pi x. Okay, that's fine. Yes, so we will take a constant minus out. So it will be 2a2 plus sin pi x. So now we are having one constant. This constant we have to find, then we will get our that final that trial function. So, but in as I told you, in least square method, whatever error function we are having, that will be our weight function. And this one we have to use here. So I will write here again. I will write here again r equal to integration wx weight function error function into dx. That's fine. So in least square method, whatever we are having wx equal to ex, and we are having ex, we already got ex, so r will be our, then limit will be 0 to l, because we got we are having that domain, like we are having this one, this 0 to l about differential equation. So okay, 0 to l 0 to l 0 to l, we are having ws ex equal to 0. So it sorry, wx and ex we are having equal, so it will be ex into again ex into dx. So we will got r equal to 0 to l e square x dx. Hopefully you got this till this. Okay, so now what we have to do, I want to minimize this r, because r is the that it contains that error, and I want to minimize that error. So we have to minimize this one, or we can say error. So what we will do normally, what we are doing, we are taking differential. Like if I will say we are having y equal to x. So for example, y equal to x square plus 2 minus 2 plus 2. Then I want to find the maximum. What we are doing, we are taking dy by dx and putting equal to 0. Right? Yes, no.
Yes, sir.
Yeah, that's fine. So now what we are going to do, we are going to differentiate that one, this error, and going to put the equal to 0. So we will get maximum or minimum. Here we want to minimize, so we will going to put it equal to 0. So del by del ai, then integration e square dx equal to 0. So just one thing you have to remember here. I put something like AI because we are not going to differentiate. We are not going to differentiate with x. So because we are not we have to find this a2. So some constant we are going to minimize because we are assuming one function a1, a2, a0. So that one we have to find exact value, some nearby exact value. So we are keeping del by del ai, and we can put here this is partial differential. We cannot put here exact differential because we don't know this function of x or function of y. It can be function of x by, it can be function of only x as well. So we are putting only uh, partial derivative here. Okay, that's fine. So we will got del by del ai integration e square dx equal to 0. Now, as we know that I will write here integration and differentiation are interchangeable. Like we can change between differential we can change integration of differential to integration. We can change into both of them. So they are interchange. We can do interchange. Like they are interchangeable. So what will happen? This integration will come out. So this integration, then it will become 2 e del e by del ai again into dx equal to 0. Okay, this 2 will go that side, so it will become integration e del ai del e by del ai dx equal to 0. This is our final equation. And we already have expression for this one. That's E. We have what we got? E equal to, we have expression E equal to minus 2a2, 2a2 or any minus only. Minus we have to change out. So minus 2a2 plus 2a2 plus 2a2 plus क्या होंगे? Plus sin pi x. Plus sin pi x. So this is our inner function. Now I'm going to put in this equation. So what we will got? Integration minus 2 minus 2 a2 plus sin pi x. इसका डिफरेंशिएट करना है तो इनटू माइनस a2 into dx equal to 0. Okay, that's good. It will be not, it will, so it will not be 2, it will be minus 2 only. So minus 2. Then minus 2 will go that side, it will go that side, so it will become 2a2 plus sin pi x dx equal to 0. And we already have limit, so I just forgot to put limit here. 0 to L and 0 to L, 0 to L, 0 to L, 0 to L. Then what we will got? Now we are going to do, so it will become 2a2x minus 1 by pi cos pi x. The limit will be 0 to L equal to 0. Then I will put here 0, so it will become 2a2L, then minus 1 by pi. Sorry. So we are having x equal to 0 and L equal to 1. So L equal to 1, we are going to put 0 to we are having L equal to 1, so it will be key cos pi. So cos pi we are having -1. That's fine. Then minus, it will be 0 minus 1 by pi equal to 0. So it will be 2a2 L. L we are having 1, so we will keep this directly 1. 1 plus 1 by pi. Then minus it will plus 1 by pi is equal to 0. Then it will be 2a2 plus 2 by pi equal to 0. Then we will get a2 equal to -1 by pi. Oh, that's good. So it's mean that we got a2 equal to -1 by pi, and we assume that our function u equal to ux equal to a2 x square minus x. Then we got u already a2, so ux equal to -1 by pi x square minus x. It means it will become ux equal to 1 by pi x minus x square. Okay, so this is our approximate solution. So this is our approximate solution that we got by using that least square method. So this is our approximate solution. And what about our exact solution? Where is our exact solution? So this is our exact solution. 1 by pi square sin pi x. So u equal to, so ux equal to 1 by pi square sin pi x. This is our exact solution. Okay, this is our exact solution, and we are having x equal to 0 and sorry L equal to, in like we are having x range 0 to 1. Okay, so I just want to show you one thing. You got something, right? Yes, no. Thank you. So like so this is our exact and approximate solution. So do you have MATLAB with you? So, but you know about MATLAB, right? So just you want to see like how much variation we are getting. So I will plot this one in MATLAB and I will show you what is like exactly happening here. Right. I will present my screen. I just want to plot both of you like both of them like approximate and exact solution. Then I just want to show you like how much difference we are getting in like in between these two solution. It is taking some time. Okay, let's move to further. So like if you plot by using some like if you plot these two functions, what you will get like this is our if I will say this is our u, this is our x. So if you plot now, you will how will get then like this you will get. Oh. Like this you will get. So this will be our exact solution, and this will be our approximate solution. This will be so. If you plot these two functions, you will get like this: exact and solution, exact and approximate. So this is like u, and if you plot the derivative of u, du by dx, this is x, and then you will get like this. So this will be our exact solution, exact, and this will be our approximate solution. I think it's open, then I will show you here. And I will present my screen then. Share now. Window. Can you see my screen?
Yes, sir.
Okay, so like I just want to show you like how much difference we are getting. So like I will write one code here. So we are having x equal to 0 to some value 0 to 1, then I will take 0.1 as a step, then 1. Then first one we are having u exact. What we got u exact equal to 1 by pi square, then 1 by pi square into sine pi into x. So this is our u exact. Then what we got u approximate. U approximate we got 1 by pi into x minus x square. Okay, so this will be our, this we have to put dot. Okay, that's fine. So then I'm going to plot these two figures. Plot x comma u exact comma x comma u approx. Okay, let's plot what they are getting. What we are getting will be u exact. Exact something. Plot. So see, can you see my screen?
Yes, sir.
So see, the like okay, I will write here again one more thing. So I will put legend. Legend. First one will be u exact. Then u rocks. for a probe. When I will see. See, as I told you, like, make it little bigger. Okay, see. So this blue one, as I told you, like here, this blue one will be our U exact, and this red one will be our U approximate, as I told you before also. So, like we are getting not getting exactly, but not that much difference. Like for example, if I will say like this one having maximum, this is having maximum value at this point. It is like, see, this one is 0.1, and at this one is like 0.49, 0.07. So this is 0.07, this is 0.07, and this is 0.01. So not that much difference. So like we are getting nearby value. So hopefully you got something. That's just want to tell, explain you by using this. Then I will stop here. I will present. So like, I told, like this will be our exact and this will be our approximate solution. Okay, now you got something, right? By doing this much derivation, I just want to, like, this one I want to tell you. Then we will solve one problem. So what problem we are going to solve? Then I will open. Still we are having half 30 minutes. We can solve one problem then. Then problem 3 we are going to solve. Using approximation function chosen above, then these all are connected. So question 1 we will solve. A bar given in the following figure is to solve for axial deformation using a strong form of method of weighted residual. Q represents the force while other symbol carry their usual meaning. Which among the following is correct representation of strong form of method of weighted residual form of the problem? That we have to find. So how we are going to solve this function? First problem. Okay. So what we have to do, we have to find the total energy. If you go through all the video, you will understand how we are going to solve all these questions. So first we have to find total energy, like total strain energy, like U equal to this is potential energy. We will say this is potential energy. Potential strain energy minus work done. strain energy minus work done. We have to do. Now, so this is our one bar. This is spring. And we are putting some load. This one is a load. So we know that bar having strain energy 1 by 2 for bar 0 to L AE du by dx whole square into dx. This is our bar strain energy. Then this will be bar strain energy. Then spring having half kx square. So half 0 to L k. Then if I will say this is total displacement u, or then what will be displacement of spring? One listening. So it will be k u square delta x minus L. And then load having breakdown by load. So breakdown by load it will be 0 to L q. This is load. Then displacement delta x minus L into dx. So now like total what will be total from our final expression? U will be 1 by 2 0 to L 1 by 2 0 to L AE du by dx square dx plus half 0 to L k u square delta x minus L dx, then minus 0 to L q u delta x minus L dx. So now this one you have to solve. To get this answer. Now, like we have to find this one. How you are going to solve? Now, setting the, like if you go through video, you will understand how we are going to solve that. We have to put that total potential energy, this one, we have to put equal to 0. So what we have to do? We have to do del u equal to 0. That one we have to do. So after doing this, what you will get? You will get one expression, something like this. 0 equal to 0. This expression you will get. I think your name Pradhan. Are you here? Are you already left? Okay. So you are from which institute? Like you are doing master or PhD? Okay, fine. So like if you have a structure, like without FEM, we cannot do anything in structure. So now by doing this, you will get this expression. And what is the second question? What they are saying? For the problem given above, okay, this problem, which one among the following is the appropriate choice of function u. Like we are assuming some approximate function and they are saying which one will be correct answer. So now we are having the four answers, and we have to choose one of the correct answer. So now what you have to do, you have to satisfy the boundary condition. So to find that any function, first we have to satisfy boundary condition. So what boundary condition we are having? Mm, like this, at x equal to 0, displacement will be 0, and x equal to L, or some distance we are having, this will be 0, L dash. So at x equal to 0, displacement should be 0. So from these four boundary conditions, we can check that at x equal to 0, this will be 0, and this will be 0, and this will also be 0. Okay. But at other support also, it should be 0. So if I will keep, it should not, then you have to derive this one. What I wrote here, satisfaction is sufficient difference and complete. So like first one, this is essential boundary condition. Only this one is that satisfying, both of satisfying, but that function let's support. But this function not satisfying boundary condition at right support. So this one will be choice. This will be our answer. Then again, if I go to third problem, using the okay, using the approximate function above. Okay, this is our approximate function u equal to c1x plus c2x square. Solve for deflection of the bar. Okay, now we have to find the deflection of the bar. So like this is our approximate function. Approximate function. Then du by dx will be c1 plus 2c2x. That's fine. But we have to find c1 and c2. Then how we are going to find c1 and c2? That we are going to use a weighted residual method. So we are going to use weighted residual method. So what is our method tell us that what our method tell us that this one should be equal to 0. So 0 to L, then 0 to L, I will keep right here, 0 to L, d by dx, ae du by dx. Okay, 0 to L, w d by dx, then ae du by dx. Okay, then dx plus 0 to L, wa, then again same thing, plus 0 to L, ae du by dx minus q ku plus ku delta x minus L dx equal to 0. This one set we are going to set 0. Now we have to put but we don't know that weight function. So we are going to assume this weight function equal to x. And if you put this all these value here, first we will assume this w equal to x, and second we will assume w equal to x square. Just we are assuming that weight function, and you will get the value. So these are like very long process. Without going through video, it will not be easy to understand for you as well. But anyway, I think whatever you are getting, that's enough, because after when you go through video, you will learn easily what I am trying to say. Yes or no? Yes, sir. Hopefully you are getting something. Then similarly in fourth problem, what they are saying, what will be the deflection at the mid-span of the bar if the bar system of problem one change as follow. Okay, what they are saying, like initially we are having like this. This is having bar, and this is connected with the spring, and again it fixed here. Okay, so this is having A, E, L. This is a Q, the Q. Okay, pushing by Q.